Hello. So, circuit simplification, circuit combination type questions. Okay. Here we have a network of resistance, infinite network. So, in such a problem, what we can say, we can assume that let net EMF, no, sorry, net resistance is X. If this entire thing has net resistance X, then this entire thing will also have net resistance X, because it is infinite series. We can take any of its part. Infinite is not completely defined. We can make use of that limitation of infinite concept. So I am redrawing this circuit. 2 ohm, 2 ohm, 1 ohm, the repetitive part. This entire is now X. And remember, how are we going to solve this problem is take these two first. So um, this is R1, this is R2, this is R3, this is R4. So R2, R4 are in parallel. So 1 upon R24 is equal to 1 upon R2 plus 1 upon R4, 1 upon 1 plus 1 upon X, X plus 1, R24 equal to X upon X plus 1. And now it is in series combination with R1 and R3. R1, R24, R3 are in series. So R is equal to this R1 plus R24 plus R3. And guess what? This R is itself X. Actually, net resistance is X. This one is X, so this one is also X. So X is equal to 2 plus X by X plus 1 plus 2. That is 4. Okay, what else we can do? Multiplying entire equation by X plus 1. Class 10th problem. 4 is there now. See, X multiplied by X plus 1, 4 multiplied by X plus 1, X upon X plus 1 multiplied by X plus 1. So it turned out to be a quadratic equation, which I think we can solve. X square minus 4x minus 4 equal to 0. Okay, that's going to be interesting. I'm going to apply Sridharacharya formula for this, and that is x equal to minus b plus minus root b square minus 4ac upon 2a. Minus b, that is 4 now, plus minus root of b square means 16, minus 4ac means plus 16. Oh my god, what is this happening? That's interesting. That's interesting. Upon 2a. So x equal to, still I can't believe this. Whether I have done something wrong, I don't know. So the answer is 2 ohm. Amazing. Oh, sorry students, there's a huge mistake because this is minus 4. So yeah, now actually I was shocked how can this will get such a simple answer. 4 plus minus, this is 32, so 4 root 2, if I'm not wrong in this time. Okay, now I'm okay. So x equal to 2 plus minus 2 root 2. And see, there is unnecessary to take negative sign. That is meaningless. So x will be 2 plus 2 root 2 ohm. Wow. Now in the same way, this capacitance part, for this capacitor, this circuit, okay, we have to see repetitive part. Entire this part is getting repeated. No, 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 no. Yeah, of course. Entire this part is getting repeated from here. So if this has capacitance C, so we can redraw this circuit like this. This capacitor, and this capacitor. And there is another one also. And now here. Okay, this entire capacitor has, entire unit has capacitance X. So this unit will also have capacitance X. So now up to you, try it out. I know this one is going to be much deadlier. Okay, I will initiate this till this quadratic equation. Later on, you have to do it yourself. All of these are in microfarad, so I'm just writing 40. Okay, all of them is has value 40. Okay, no problem with that. So this is C1, this is C2, this is C3, this is C4, this is C5. So C1, C2 are in parallel. So C12 is equal to 40 plus X. That's all. Now C12 and C3 are in series. So 1 upon C123 is equal to 1 upon C12, 40 plus X, plus 1 upon 40. Oh, I have taken such a huge values. This is going to be lengthier. 40 and this, I'm directly writing 80 plus X. So C123 is 40 plus X upon 80 plus X. Till here we have done. Now C123 and C4 are in parallel. C123 and C4 in parallel. So that is much easier. Parallel, to handle parallel in capacitors is much easier. So that is 40 plus X upon 80 plus X plus 40. 80 plus X, 40 plus X plus 40, 80 plus X. If we take 40 common, I don't know whether it will be good or not, but something which we can do to simplify the things. And now it is in series combination with this C5. 1 upon C1234. Difficult. So this will be 80 plus X upon 40, 120 plus 2X and plus 1 upon 40. 40, 120 plus 2X is 80 plus X plus 120 plus 2X. That is 200 plus 3X. So C equal to 40, 120 plus 2X upon 200 plus 3X. And that is equal to X. Since C is equal to X, so X is equal to 40, 120 plus 2X upon 200 plus 3x, and now it will turn into a quadratic equation, and then you can solve it. Oh, I'm leaving it. Okay, here the question is find current through each resistor. All right, so uh, maybe they can ask find total current. Oh, in steady state. Remember student, whenever there is capacitor and resistor both in the circuit, when circuit is just switched on or switched off, we um, it is difficult to find current because of some certain reason. I don't want to go into it. That is not in the syllabus, so I don't want to talk about that. But when there is a capacitor in the circuit and we just switched it on, there is a small current flows through the circuit. But after some time, after few seconds, no current flows. I'm talking about DC. In AC still it conducts, current flows through it. And once again there is a very long description for that. I don't want to go into it. So what I'm going to say that in steady state means we have switched the circuit on and we have it is on for a long time. So in steady state, capacitor in steady state from question I'm writing the answer, no current flows through the capacitor. Student, today I'm unable to write properly. I don't know, maybe some stiffness in my wrist. Okay, so I'm marking it R1, R2, R3. So this R3 will be cut off from the circuit. So R3 is ineffective. And now we have only this circuit. In fact, this capacitor will also not work. But if current is flowing here, see, it is not allowed to flow, allow current to flow through it. So this part of the circuit is cut off. Here, current can go here and here. Not here, no problem. It can still go through these two resistors. So R1, R2 are in parallel. You can directly write this. R12 equal to 5 by 2, that is 2.5. This is my direct method. If two resistor, 2, 3, whatever number of resistors are there, then and they are same, equal, then just take their average. That's all. And now current through each resistor. So through R3, current through R3, I mean I3 is 0. All right. Actually, it wasn't required. We can directly do this. Whatever with the potential difference here will be same as here. So we can consider it as two different circuits, and both will have same 5 ohm resistor. So anyway, as we have calculated it, I will use it. So okay, I equal to E upon R plus R. E is 36, R is 2, another R is 2.5, so it is 4.5. Maybe 8 za, you can check it out. Maybe I would be wrong. So okay, so this is 8 ampere. 8 ampere is being delivered from here. So what is the potential difference across these two? V12 equal to I12 R12. 8 into 2.5, that is 20 volt. So I1 equal to V1 upon R1. V1 because both are in parallel. V12 will be equal to V12 will be equal to V1 as well as V2 because it is same in parallel. So V1 is 20 upon R1 is 5, which is 4 ampere. I2 V2 upon R2, oh sorry, I1 V1 upon R1 20 upon 5 equal to 4. I2 V2 upon R2 again 20 upon 5 equal to 4. Few students can say that it was 8 ampere, both resistor were equal, then equally divide this current would do work. But see, if they would not be identical, they would be different, then you have to go through this method. Find potential difference across them, their combination, and then that potential difference for combination will be the potential difference for individual, and then you can find current by using this formula. Same question is there. Here I'm writing that find net current, I total. So once again, there is a capacitors under steady state. The circuit ahead of that capacitor will be ineffective. So no current is flowing through this way. Nothing is going here. Some people can say that current may get into this circuit through this way, but where will current go? It require a closed circuit. So R1, R2, R3, R4, R5, R6, R7, R8. We can write that due to capacitor, R4 to R8 are ineffective because there is no current. And that's all. Now this is our question, so I'm not going to do this. Now this is the most favorite question of teachers and board also. Quite annoying type of question it is, but very easy, and you can directly you have to give no explanation for that. So but I am explaining you why is it so. I'm marking this point as x, this point y, this point z, this point w, and I am consider this yz point, yz, and I am marking this 2 ohm resistor here. Then from z, okay, z is short circuited to y, and as I said that this wire can be reduced to a single point, so uh, sorry, it was x. Anyway, z is short circuited to x, so the point which is z, it is same as x, and it is same as a. This point is a, and in the same way y point is also w and also b. We have connected yz 2 ohm. Now I have to connect z with w. Z is here, w is there. I have to go through another wire. Now y with x. There is y, there is x. So given resistors are in parallel. R's are in parallel. So that's all. Same thing here and same thing here. Find equivalent EMF. So all of them are in parallel. All of them are equal. It is 1.5. Different. So we have to apply that formula for different cell because of this EMF is different. So you can do it. So in such type of question, just print these type of question in your mind. You have to consider this as parallel combination. These capacitors are in parallel combination. These cells are in parallel combination. like this. Then you can solve